Before we dive in, a quick but important note. This presentation is for informational and educational purposes only. The career paths, timelines, and salary figures discussed are based on my research and experience, but they are not a guarantee of income or employment. Your personal success will depend on your own effort, skills, and the market conditions at the time you apply. This is a roadmap, not a lottery ticket. Alright, let's get into it. Forget everything you've been told about breaking into tech. Forget the 4-year computer science degree being the only mandatory path. Forget the myth that you need to be a math prodigy who was born coding. I am telling you right now with absolute certainty that it is entirely possible to go from where you are today, whether you're a barista, a truck driver, an artist, or just feeling completely stuck in a dead-end job, to earning a 6-figure salary as a computing engineer in the United States by 2026. That's not a wish. It's not a guess. It's a timeline. And in this video, I am going to hand you the exact step-by-step roadmap to make that a reality. But let's be brutally honest for a second. If it were that simple, everyone would already have a 6-figure tech job. The reality is that right now, you are probably drowning in a chaotic sea of conflicting advice. You watch one YouTube guru who swears you have to learn Python because data is the new oil. Then you click on the next video, and a different expert insists that Rust is the future and learning anything else is a waste of time. Your cousin, who works in IT support, tells you that you have to get a CompTIA A+ certification and learn networking. Meanwhile, your social media feed is filled with ads for coding bootcamps, all promising to land you a job in 6 months for the low price of $20,000. So maybe you take the plunge. You spend nights and weekends grinding, you graduate with a cookie-cutter portfolio, and you step out into the job market, excited and ready. And then silence. You fire off 100 applications into the black hole of online job portals. 200 applications. 300. The only replies you get are automated rejections, telling you they've decided to pursue other candidates whose skills more closely match their needs. You start to feel your confidence crumble. You look at your portfolio, the same to-do list app, the same weather app, the same calculator clone as thousands of other bootcamp grads, and a terrifying thought creeps in. Maybe I'm just not cut out for this. You see the headlines about massive tech layoffs at famous companies, and you start to wonder, is the dream dead? Is it too late to get in? Let me be clear. The dream is not dead. But the map that everyone is using, the map that worked in 2018 or 2020, that map is now completely, utterly useless. Following that old advice today is like trying to navigate New York City with a map from the 1800s. It will lead you straight off a cliff of frustration and debt. This video is the new map. This is your updated GPS, specifically calibrated for the fiercely competitive, AI-driven, post-layoff US tech landscape of today. We aren't just going to give you a list of programming languages. This is a strategic, year-by-year battle plan for the remainder of 2024, all of 2025, and the beginning of 2026. We will break down in painstaking detail what you need to be doing this year to forge an unbreakable foundation, what you must accomplish in 2025 to build undeniable, irrefutable proof of your skills, and the precise surgical steps to take in early 2026 to start landing multiple 6-figure job offers. By the time you finish this presentation, you will have a crystal clear, actionable plan. No more confusion, no more self-doubt, no more guesswork, just a direct path from where you are now to where you deserve to be. So why is the old way so broken? What changed? 2 seismic shifts have permanently altered the industry. First, the explosion of artificial intelligence. Tools like GitHub Copilot and ChatGPT aren't just novelties anymore. They are standard issue in every professional software development team. This means the value of simply being able to write basic boilerplate code has collapsed. Companies are no longer looking for human code monkeys who can just translate instructions into syntax. They are looking for true engineers, people who can think critically about system design, solve ambiguous and complex business problems, and leverage AI as a tool to build solutions faster and more effectively. Your value is no longer in your fingers, it's in your brain. Second, market saturation. The secret is out. Everyone and their dog knows that tech is one of the last reliable paths to a comfortable middle-class life in America. This has created a tidal wave of aspiring developers. The entry-level market is now brutally competitive. A generic resume that lists HTML, CSS, JavaScript, and a link to your GitHub with a few tutorial-based projects is completely invisible. It's white noise. To stand out today, you can't just show you can code. You have to prove you can engineer. You have to demonstrate that you can deliver real-world value. Our 2026 roadmap is engineered from the ground up to conquer these two challenges. It's not about just learning to code. It's about learning to think, problem solve, and build like a professional engineer. It's not about creating a portfolio. It's about forging a weaponized collection of proof that makes you an undeniable, must-interview candidate. The entire system is built on 3 unbreakable pillars. Get these 3 right, and your success is practically an inevitability. Get even one of them wrong, and you'll stay stuck on the hamster wheel. Pillar 1 is foundational mastery. Notice I didn't say foundational knowledge. Mastery is different. This isn't about learning 10 different programming languages at a surface level. It's about achieving deep, intuitive, unshakable competence in one specific, high-demand technology stack, and understanding the core computer science principles, like data structures, algorithms, and system design, that never go out of style. We're talking about knowing your tools so well that you can build complex applications from a blank screen, without needing to constantly look up basic syntax or follow a tutorial. This is what separates the hobbyist from the professional. Pillar 2 is project-based proof. This is where we completely incinerate the old model of building generic portfolio projects. You will not be building a calculator. You will not be building another Netflix clone. Instead, we're going to focus on creating 1, maybe 2 what I call career maker projects. These are unique, complex applications that solve a genuine problem. Maybe a problem you have in your own life or in your community. They showcase a wide range of technical skills and, most importantly, give you a fascinating story to tell in a job interview. Imagine the difference. Instead of saying, "Here's a to-do list app 1 built," you say, "I noticed that local animal shelters were struggling to manage volunteer schedules. So I built a full-stack application that automated their scheduling, processed new volunteer applications, and reduced their administrative overhead by 15 hours a week." Who do you think gets the job? This is your proof of work. It's the evidence that you're not just a learner. You're a builder and a problem solver. And Pillar 3, the one that 95% of aspiring developers get tragically wrong, is strategic networking. Now, when I say networking, I know what you're thinking. Slimy, awkward conversations and spamming connection requests on LinkedIn. Forget all of that. I'm talking about a targeted, genuine system for building real relationships with engineers and hiring managers at the specific companies you want to work for. A single referral from an employee inside a company can be more powerful than 500 applications you submit through the online portal. A referral gets your resume taken out of the giant slush pile and placed directly into the hands of a human being. We are going to turn your cold, lonely job search into a series of warm introductions. Throughout this series, we will dedicate entire sections to each of these pillars, breaking them down into monthly and quarterly goals. We'll analyze exactly which tech stacks, from web development to cloud engineering to data, are the most profitable and have the most robust hiring markets in the US right now. I'll give you a complete framework for brainstorming, planning, and executing a career maker project that will make recruiters' jaws drop. And I will share the exact scripts, templates, and strategies I've used to build a professional network that lands interviews at dream companies without ever clicking that Apply Now button. We are starting with the rest of 2024. This is the foundation year. The work you do here, building your foundational mastery, is the concrete slab upon which your entire career will be built. If you get this first phase right, everything that follows becomes 10 times easier. So grab a notepad, turn off your phone's notifications, and get ready to focus. The journey to your 6-figure computing engineering career starts right now. Let's begin with the single most important decision you will make this year: choosing your battlefield. In the world of technology, there are countless paths, hundreds of specializations, and 1,000 different job titles. It's a sprawling, confusing landscape, and if you charge into it without a map, you'll get lost. You'll waste months, maybe even years, learning skills for a role you end up hating, or worse, a role that's becoming obsolete. Choosing your battlefield isn't just about picking a job title. It's about understanding the fundamental nature of the work. It's about aligning your innate talents and your personality with a domain where you won't just succeed, but you'll thrive. Because let me tell you, a 6-figure salary feels a lot better when you don't dread logging on every single morning. For our 2026 roadmap, we're focusing on the 3 dominant, high-growth, and high-paying territories in the computing engineering world. These are the arenas where demand is exploding, and where companies are willing to pay top dollar for true talent. They are software engineering, data science and artificial intelligence, and cybersecurity. Let's start with the bedrock, the foundation upon which the entire digital world is built: Software engineering. Think of software engineers as the architects and master builders of our time. They don't work with steel and concrete. They work with logic and code. They build the apps on your phone, the websites you browse, the operating systems that run your computers, and the complex systems that power global finance and logistics. If you're the kind of person who loved Legos as a kid, who gets a deep sense of satisfaction from building something from scratch and seeing it work, this is your domain. It's a world of problem solving. Every day is a new puzzle. How do we make this website load a millisecond faster? How can we design a database that can handle 1 million users at once? How do we create a user interface that feels intuitive and effortless? Within this massive battlefield, there are two main fronts. You have the front-end developers, the artists and user experience gurus. They build everything you see and interact with. The buttons, the menus, the visual layout. They use languages like JavaScript and frameworks like React to create beautiful, responsive experiences. Then you have the back-end developers, the engineers of the digital world. They build the engines that you never see. The servers, the databases, the APIs. They work with languages like Python, Java, or C# to handle the logic, security, and data that makes the front end possible. And of course, you have full-stack developers, the versatile commandos who can operate on both fronts. The path of the software engineer is for the logical, the patient, and the persistent. It's for people who can stare at a screen of code for hours, hunting for a single misplaced semicolon that's bringing the whole system down. The reward? You get to be a creator. You build the tools that shape the future. By 2026, the demand for skilled software engineers who can build robust, scalable, and efficient applications isn't just going to be high. It will be a fundamental necessity for every company on the planet. This is the surest, most well-trodden path to a six-figure career. But what if you're less interested in building the machine, and more fascinated by what the machine can tell you? What if you want to predict the future? That brings us to our second battlefield: data science and artificial intelligence. Think of data scientists and AI engineers as the oracles and chief strategists of the modern era. In the past, kings had mystics to guide their decisions. Today, CEOs have data scientists. These professionals dive into oceans of information: sales figures, user behavior, market trends, sensor readings, and they emerge with priceless intelligence. They find the hidden patterns, the subtle correlations that no human could ever spot. They answer critical questions. Which customers are about to leave us? What's the perfect price for our new product? Where should we build our next warehouse? This field is a unique blend of three distinct skills: computer science, statistics, and business acumen. You need the programming skills to wrangle massive datasets, the statistical knowledge to build accurate predictive models, and the business sense to understand what questions are worth asking in the first place. This is the domain for the intensely curious, the person who is never satisfied with the surface-level answer, the person who constantly asks, why? And then there's its superstar sibling, artificial intelligence, specifically machine learning. This is where you don't just analyze the data, you teach the computer to learn from it. You build the algorithms that power Netflix's recommendation engine, the AI that's learning to detect cancer in medical scans, and the large language models that are changing the world as we speak. The AI revolution is not a fad. It is the single biggest technological shift of our generation, and we are only in the first inning. By 2026, companies that are not leveraging AI will be left in the dust. And the people who can build, train, and deploy these AI systems, the AI and machine learning engineers, will be the new kingmakers, commanding astronomical salaries for their rare and powerful skills. If you are a strategic thinker, a lover of statistics, and fascinated by the prospect of creating intelligence itself, this is your battlefield. We've talked about building the kingdom with software engineering and guiding its strategy with data and AI. But a kingdom with no walls is destined to fall. This leads us to our third and final battlefield: cybersecurity. Think of cybersecurity professionals as the guardians on the wall, the sentinels of the digital realm. They operate in a world of constant, invisible warfare. Every single second of every single day, corporations, governments, and hospitals are under attack from hackers, criminal syndicates, and rival nation-states. The cybersecurity expert is the one standing between a company's priceless data and total chaos. This is not a field for the faint of heart. It's for the person who thinks differently. To catch a thief, you have to think like a thief. Cybersecurity analysts have to be professionally paranoid. They look at a perfectly good system and their first thought is, how can I break this? They hunt for vulnerabilities, patch weaknesses, and build digital fortresses. They are the digital detectives who, when a breach does happen, follow the breadcrumbs to find out who did it, how they did it, and how to make sure it never happens again. This domain is perfect for those who thrive on adrenaline and responsibility. You're not just fixing a bug. You're protecting people's identities, their savings, and their privacy. The roles here are diverse. Ethical hackers or pentesters are hired to legally break into systems to find flaws. Security architects design impenetrable networks. Incident responders are the first responders to a digital fire. With every new technology, with every device connected to the internet, the attack surface grows, making the world more vulnerable. Because of this, the demand for cybersecurity talent is outstripping supply at a terrifying rate. By 2026, there will be millions of unfilled cybersecurity jobs in the US alone. This is basic supply and demand. When demand is infinite and supply is limited, the price, your salary, goes through the roof. If you have a meticulous, detail-oriented mind, a calm demeanor under pressure, and a deep-seated desire to protect and defend, then your battlefield is cybersecurity. So there they are, the three primary battlefields for your 2026 campaign: the builder, software engineering; the strategist, data science and AI; and the guardian, cybersecurity. Now you must choose. Don't just pick the one that sounds the coolest or has the highest potential starting salary. Stop and ask yourself three simple questions. 1. What kind of problem energizes you? Building something new, predicting what will happen next, or defending against a threat? 2. What is your natural thinking style? Are you a logical, step-by-step constructor? An inquisitive, pattern-seeking analyst? Or a skeptical, detail-oriented protector? And 3. Where do you want your impact to be felt most? In the hands of users, in the decisions of leaders, or in the safety of our digital infrastructure? Take a moment. Be honest with yourself. This decision will be the compass that guides every other choice you make on this journey. You've now surveyed the terrain. You've seen the major fronts where the war for talent is being waged. You've considered your own strengths and inclinations. You have chosen your battlefield. But a warrior with no weapon is just a target. A builder with no tools cannot build. A guardian with no shield cannot defend. In the next part, we're going to the armory. We are going to forge the single most important weapon in your entire arsenal, the one non-negotiable skill every single one of you needs to master regardless of the path you choose. We're going to talk about the universal language of power in the 21st century: code. But let's be brutally honest for a second. The word code is intimidating. It conjures images of incomprehensible green text scrolling on a black screen, of sleepless nights fueled by energy drinks, of a secret club you weren't invited to. I'm here to tell you that's a myth. It's a wall built to keep people out. We're going to tear that wall down brick by brick. Because here's the secret. Learning to code isn't about memorizing 1,000 weird commands. It's not about being a math genius. It's about learning a new way to think. It's about learning to take a giant, messy, real-world problem like building a social media app or predicting stock prices, and breaking it down into a series of tiny, simple, logical steps that a computer, an obedient but incredibly dumb rock we tricked into thinking, can follow. That's it. That's the entire game. The language you use, that's just the grammar. The syntax. Whether you say tomato or tomato, the underlying logic, the problem solving, is the same. And once you master that logic in one language, you can pick up any other language in a matter of weeks. You become fluent in the idea of programming, not just a single dialect. So the million-dollar question, the one that paralyzes millions of beginners in an endless cycle of YouTube tutorials and forum debates. Which language do I learn first? You've seen the holy wars online. Python is the best. No, JavaScript is the future. You're all fools. C++ is the only way to be a real programmer. It's overwhelming. It's confusing. And it's the single biggest reason people quit before they even start. So let's cut through the noise. Right now, for your 2026 roadmap, we're not going to list 20 languages. We are going to focus on 3 strategic entry points. 3 pillars that support virtually every 6-figure computing job in the United States. Think of this as choosing your starting class in a video game. Each has unique strengths, each leads to a different adventure, but all of them can lead you to the treasure. These pillars are Python, JavaScript, and the C family, specifically C++ or Java. Let's start with the crowd favorite, Python. If you know nothing, and I mean absolutely nothing about programming, Python is your best friend. It was designed from the ground up to be readable. In fact, Python code often looks a lot like plain English. This isn't a small detail. It means you spend less time fighting with confusing symbols and semicolons, and more time actually learning the core concepts of logic and problem solving. Think of Python as the Swiss Army knife of the programming world. It might not be the absolute best tool for every single specialized job, but it's incredibly good at almost everything. You want to get into the sexiest field in tech right now, artificial intelligence and machine learning? That entire world runs on Python. The libraries, the frameworks, the research papers, it's all Python. You want to be a data scientist, pulling insights from massive datasets for companies like Netflix and Spotify? Python is your weapon of choice. You want to build the backend of a website, the hidden engine that powers the user accounts and databases? Python with frameworks like Django and Flask is a top-tier contender. It's the ultimate generalist language. Learning Python doesn't just open one door. It opens a dozen. It's the path of least resistance to a massive number of high-paying jobs, and for that reason alone, it's arguably the #1 strategic choice for a beginner in 2024 aiming for a 2026 career. But maybe you're a more visual person. Maybe the idea of working on invisible server logic or abstract data models doesn't excite you. You want to build things that people see, click, and interact with. You want to create beautiful, responsive websites and slick mobile apps. If that's you, then welcome to the kingdom of JavaScript. Let me be clear. JavaScript is not an optional language for the web. It is the web. Every time you see a pop-up, a cool animation, a live-updating newsfeed, or an interactive map on a website, you are looking at JavaScript in action. It is the one and only language that runs natively in every single browser, from Chrome to Safari. For decades, it was confined to the browser, seen as a simple scripting language for making websites pretty. But then a revolution happened. With the creation of Node.js, developers figured out how to let JavaScript escape the browser and run on servers. This changed everything. Suddenly, you could use one single language, JavaScript, to build both the front end, the part the user sees, and the back end, the server logic. This is the full-stack dream. Companies love it because they can hire one developer to do the work of two. And developers love it because you can build a complete, complex application from scratch using a single skill set. With frameworks like React, Angular, and Vue for the front end, and Node.js for the back end, the JavaScript ecosystem is the most vibrant, fast-moving, and in-demand skill set for web and mobile application development. If your goal is to be a versatile builder of the things people use every day, JavaScript isn't just a choice. It's a necessity. Now for our third pillar. This one is different. Python is the friendly guide. JavaScript is the master of the web. The C family, specifically C++ and Java, is the bedrock. This is the path for those who aren't satisfied with just knowing what to do, but are obsessed with understanding how it works on a fundamental level. Learning C++ or Java is like deciding to learn mechanical engineering instead of just learning how to drive a car. You will be forced to understand concepts that other languages hide from you. You'll learn how your computer's memory actually works, how the processor crunches numbers, and how to write code that is blisteringly fast and ruthlessly efficient. There's a reason why the most demanding software in the world is built with C++. We're talking about high-frequency trading systems where a microsecond of delay can cost millions of dollars. We're talking about the core engines of blockbuster video games that need to render breathtaking graphics in real time. We're talking about operating systems, the very foundation of our digital lives. Java, its slightly more corporate cousin, holds a similar position of power. It's the silent giant that runs the world of large-scale enterprise. The vast majority of Fortune 500 companies have massive mission-critical systems built on Java. The Android operating system, running on billions of devices worldwide, is built on Java. It's a language built for stability, security, and performance at an enormous scale. The learning curve for these languages is steep. It's a cliff face compared to Python's gentle slope, but the reward is immense. Developers who master C++ and Java are often the highest paid in the industry because they are trusted to solve the hardest, most performance-critical problems. Choosing this path is a declaration that you want to be an engineer's engineer. You want to build the foundation that everyone else builds upon. So how do you choose? Simpler than you think. Don't ask which language is best. Ask which problems excite you the most. Are you fascinated by data, intelligence, and the future of AI? Start with Python. Do you dream of building the interactive websites and apps that define the modern user experience? Start with JavaScript. Are you obsessed with speed, performance, and understanding how the machine truly works at its core? Brace yourself and start with C++ or Java. Pick one, just one, and commit to it for the next 6 months. Because learning the syntax of a language is just the beginning. It's like learning the alphabet. It's a critical first step, but it doesn't mean you can write a novel. To do that, you need to learn how to combine those letters into words, and those words into powerful, elegant sentences. In programming, that means learning the fundamental principles that transcend any single language. It means learning how to structure your data, and how to write algorithms that solve problems efficiently. This is the single most important concept you will ever learn in your entire software engineering career. Forget frameworks, forget the hot new language of the week. Data structures and algorithms, or DSA, is the foundation upon which everything else is built. It's the difference between a cook who can only follow a recipe and a master chef who understands the chemistry of food. The cook can make a decent meal, but the chef can invent a new one. The cook is replaceable. The chef is invaluable. Think of it this way. Data structures are simply ways of organizing and storing data. An array is a list of items in a row like books on a shelf. A hash map is like a dictionary, where you can look up a definition, the value, instantly by knowing the word, the key. A tree is like a family tree, showing relationships and hierarchy. Each structure has specific strengths and weaknesses. Choosing the right one is like a carpenter choosing between a sledgehammer and a finishing nailer. Using the wrong tool for the job is slow, inefficient, and often breaks things. Algorithms, on the other hand, are the step-by-step instructions for manipulating that data. They are the recipes. How do you find the fastest route between 2 points on a map? That's an algorithm. How do you sort a million names alphabetically in the blink of an eye? That's an algorithm. How does Netflix recommend the next show you'll binge watch? That's a very, very complex algorithm. Mastering DSA is what separates the six-figure engineer from the code monkey who gets stuck on the first layoff list. Because when you understand DSA, you're not just writing code. You're architecting solutions. You can look at a massive, complex problem and see the underlying patterns. You can anticipate bottlenecks before they happen. You can build systems that are not just functional, but fast, scalable, and efficient. That is the skill companies are paying top dollar for. They don't pay you to write for loops. They pay you for your problem-solving ability, and DSA is the language of computational problem-solving. So where do you start? It can seem like a mountain, but it's a mountain you climb one step at a time. Let's build your toolkit. First, the core data structures you absolutely must know inside and out. 1. Arrays and strings. These are your bread and butter. You need to know how to access, insert, and delete elements, and understand the cost of those operations. 2. Hash maps, also known as dictionaries. This is arguably the most important data structure in modern programming. It allows for near-instantaneous lookup, insertion, and deletion. Anytime you hear "we need this to be fast," your brain should immediately think hash map. 3. Linked lists. While less common in day-to-day application code, they are critical for understanding memory management and are a favorite in technical interviews. They teach you how to think about pointers and data that isn't stored contiguously. 4. Stacks and queues. Think of a stack of plates, last one on is the first one off, and a queue at the grocery store, first one in is the first one out. These simple structures are the basis for everything from your browser's back button to processing tasks in a system. 5. Trees. Specifically binary search trees. They allow for data to be kept in a sorted order, while still allowing for fast lookups and insertions. They introduce the concept of hierarchical data. And finally, 6. Graphs. The most complex but also the most powerful. A graph represents a network of connections, think Facebook friends, the internet itself, or the road system on Google Maps. Understanding graphs is your entry ticket to solving a huge class of real-world problems. Once you have a handle on how to store the data, you need to learn how to work with it. That means algorithms. You don't need to memorize hundreds, but you need to deeply understand the core concepts. First, sorting. Algorithms like merge sort and quicksort are classics. Studying them isn't about re-implementing a sort function. It's about understanding the concept of big O notation, a way to measure an algorithm's efficiency. It teaches you the difference between a solution that takes a millisecond and one that takes a century as the input grows. Second, searching, specifically binary search. This is the classic divide and conquer strategy. It's the most efficient way to find an item in a sorted list, and is a fundamental pattern you'll see everywhere. Third, graph traversal. Algorithms like breadth-first search, BFS, and depth-first search, DFS, are your tools for navigating networks. They answer questions like, what's the shortest path from A to B? Or, can I even get from A to B? And fourth, recursion. This is a mind-bending but crucial concept where a function calls itself to solve a smaller version of the same problem. It's the key to solving complex problems, especially those involving trees and graphs, in an elegant way. Okay, that's the curriculum. But how do you actually learn it? You need a tool, a programming language to practice with. This is where people get paralyzed. They spend months debating the best language. Let me make it simple for you. For this stage, your goal is to pick a language with simple, clean syntax so you can focus on the logic of the DSA, not the boilerplate of the language. For 90% of you, the answer is Python. Its syntax is as close to plain English as you can get. It reads like pseudocode. This means you can translate the idea for an algorithm in your head into working code with minimal friction. It has a massive community and endless learning resources. It allows you to focus on the problem solving, which is the entire point of this phase. The other fantastic option is JavaScript. If you know for a fact you want to go into web development, starting with JavaScript makes sense. It's the language of the browser, and with Node.js it can power the backend too. It's a bit quirkier than Python, but learning DSA with it will directly translate to the work you'll be doing. What about languages like Java or C++? They are incredibly powerful and dominant in many industries, but their syntax is more verbose and they require you to manage more details like static typing. This can be a distraction when you're just trying to wrap your head around how a linked list works. You can and should learn them later when you specialize. But for learning the fundamentals, choose the path of least resistance. Choose Python or JavaScript. Now, here is your concrete 6-month plan to master the fundamentals. Months 1 and 2 are your language bootcamp. Pick Python or JavaScript and live in it. Your goal is not mastery, but comfort. You need to be able to write variables, loops, conditional statements, and functions without having to look up the syntax every 5 minutes. Build a few tiny, simple projects, a number guessing game, a simple calculator. Get your hands dirty. Months 3 through 6 are the DSA deep dive. This is the main event. First, get a structured resource. Don't just watch random YouTube videos. Enroll in a high-quality online course like the University of California, San Diego's Data Structures and Algorithm Specialization on Coursera, or find a well-regarded course on Udemy. This provides a roadmap. Second, get a book. I highly recommend Grokking Algorithms. It uses fantastic illustrations to explain complex topics. It's the perfect visual companion to a more formal course. Third, and this is non-negotiable, you must start practicing on a platform like LeetCode or HackerRank. This is your gym. This is where you turn theory into skill. Start with the easy problems. Your goal is to solve at least one problem every single day. First, it will be hard. You'll get stuck. You'll spend an hour on a problem only to look at the solution and realize it was 5 lines of code. This is normal. This is the process. You are not just learning to code. You are rewiring your brain to think like a programmer. You're building the mental muscles for pattern recognition. After a few months of this consistent practice, something incredible will happen. You'll look at a new problem, and instead of seeing a confusing wall of text, you'll start to see the patterns. You'll think, this involves finding the shortest path. That sounds like a graph problem. I should use breadth-first search. Or, they need fast lookups based on a username. This is a perfect use case for a hash map. This is the inflection point. This is when you transition from someone who just writes code to someone who engineers solutions. You've now built the universal toolkit that applies to every single area of software development, from building iPhone apps to training artificial intelligence models. You've learned the grammar and the core vocabulary. You now have the fundamental building blocks. But a pile of perfect bricks doesn't make a house. You have to assemble them into something meaningful. It's time to stop doing abstract exercises and start building real, tangible projects that will get you noticed and get you hired. But what should you build? How do you choose a project that showcases these newfound skills and makes a hiring manager's jaw drop? That is the next critical step on our roadmap to a 6-figure career. The biggest mistake aspiring engineers make isn't in the code they write. It's in the problems they choose to solve. We've all seen them. The endless sea of cookie-cutter portfolio projects. The to-do list app, the weather app, the basic calculator. These projects don't get you hired. They get you ignored. Why? Because they tell a hiring manager absolutely nothing about you, other than the fact that you can follow a tutorial. They show no creativity, no passion, and no real-world problem-solving ability. A hiring manager isn't just looking for a code monkey. They are looking for a problem solver. They have a business to run, products to ship, and fires to put out. They are looking for an engineer who can understand a problem, architect a solution, and see it through to completion. Your portfolio project is your single greatest opportunity to prove you are that person before you ever step into an interview. It's your audition tape. So you can't just build something. You have to build the right something. The secret lies in a framework I call the project trifecta. Every killer portfolio project, the kind that lands you a six-figure job, has three essential components. If your project idea doesn't tick all three of these boxes, scrap it and find one that does. First, it must be driven by a genuine passion or solve a personal problem. This is the non-negotiable foundation. Why? Because passion is infectious, and it's the fuel that will get you through the inevitable late nights of debugging. When you're in an interview and they ask you to talk about your project, do you want to list off the features of a generic to-do list with a flat, bored tone? Or do you want your eyes to light up as you explain the custom-built application you created to help you and your friends manage your Dungeons & Dragons campaign? Complete with a character sheet generator and a real-time dice rolling simulator? Think about your hobbies, your frustrations. What is a small nagging inconvenience in your life? Are you a coffee enthusiast? Build an app to log your pour-over recipes and tasting notes. Are you a gym rat? Create a tool that visualizes your lifting progress in a way that no existing app does. Are you trying to learn a new language? Build a flashcard system that uses a spaced repetition algorithm you designed yourself. When you build something you genuinely care about, you'll build it better. You'll add features no one told you to add. You'll polish it. And most importantly, when you talk about it, you'll be telling a story, not just listing specs. That's what a hiring manager remembers. The second part of the trifecta is a strategic technology showcase. Your project is a billboard advertising the skills you want to be paid for. This is where you connect the skills from the last step directly to a tangible result. You don't build a project and then list the tech you happen to use. You decide on the tech you want to master for your target job, and then you design a project that forces you to use it. Want to be a front-end developer specializing in React? Your project must be a dynamic, single-page application built with React, using hooks, state management like Redux or Zustand, and interacting with a REST or GraphQL API. Want to be a back-end engineer? Build that API. Design it from scratch using Node.js and Express, connect it to a PostgreSQL database, and implement user authentication with JSON Web Tokens. Want a full-stack role? Do both. The goal here is to demonstrate proficiency in a modern in-demand stack. Look at the job descriptions for the roles you want. What technologies appear over and over? That is your blueprint. Your project should mirror the architecture of a real-world application, even if it's on a smaller scale. This shows you're not just a learner. You're a builder who is ready to contribute to a professional team from day one. And that brings us to the third and most crucial piece of the trifecta. It must solve a real-world problem and demonstrate your engineering thought process. This is what separates the six-figure candidates from the rest. It's not enough to build something cool. You have to show how you built it and why you made the decisions you did. This is where documentation becomes your secret weapon. Your project's home on GitHub shouldn't just be a folder of code. The README file is your sales pitch. It needs to be pristine. It should start with a clear, concise explanation of the problem you are solving. Not "this is a to-do list app." But modern productivity apps are often bloated with unnecessary features. I built a minimalist task manager focused on the Pomodoro technique to enhance focus for students and freelancers. See the difference? One is a description, the other is a value proposition. Then you document your process. What were the technical challenges you faced? Maybe you struggled with asynchronous state updates in React. Talk about it. Explain how you researched the problem, the different solutions you considered, and why you ultimately chose the one you did. Did you have to design a database schema? Include a diagram and explain your choices for the tables and relationships. This documentation transforms your project from a simple piece of software into a case study of your engineering mind at work. You are showing them, not just telling them, that you can think like an engineer. You can analyze trade-offs, solve complex problems, and communicate your solutions effectively. That is the single most valuable skill you can demonstrate. Let's imagine two candidates interviewing for the same junior developer role. The first candidate, Alex, presents a weather app. It's clean, it works, it pulls from a public API. The interviewer asks, "Tell me about this project." Alex says, "Well, I wanted to practice fetching data from an API, so I built an app that shows the weather." The conversation dies there. It's a technical exercise. Then comes Ben. Ben presents an app called Trailhead, a tool for hikers to find and share information about local trail conditions in real time. The interviewer asks, "Tell me about this project." Ben's face lights up. "I'm a huge hiker," he begins, "and I was always frustrated that the official park websites were out of date. I drive an hour to a trail only to find it closed or washed out. So I built a platform where users can submit real-time updates and photos." He then proceeds to talk about the technical challenges. "I used the MERN stack. For the backend, I built a REST API with Node.js and Express. The trickiest part was handling the location data. I decided to use MongoDB because its GeoJSON support is fantastic for building queries like find all trails within a 10-mile radius. On the front end, I used React and the Mapbox API to display the interactive map, which was a challenge because I had to manage hundreds of data points without slowing down the user experience. I implemented client-side clustering to solve that. Who are you hiring? It's not even a contest." Ben didn't just show he could code. He showed passion, initiative, problem-solving skills, and an understanding of how technology can be used to create real value. He told a compelling story. "Alex just completed a homework assignment. So your mission for this phase of the roadmap is to brainstorm and execute your trifecta project. Find that intersection of your personal passion, the tech stack you need to learn, and a real problem you can solve. Spend the next 1 to 2 months not just building it but living it. Obsess over it. Make it your masterpiece. Document every decision, every failure, and every breakthrough in a detailed README. Deploy it to the web so anyone can access it. Once you have this cornerstone project, this tangible proof of your skill and your passion, it changes everything. It becomes the star of your resume, the centerpiece of your portfolio, and the main topic of conversation in your interviews. But having a world-class project sitting silently in a GitHub repository isn't enough. You need to build the stage to show it off. You need to craft a digital presence, a resume, a portfolio, and a personal brand that forces recruiters and hiring managers to stop scrolling and pay attention. And that is exactly where we're going next. Let's start with the silent killer of countless job applications, the resume. Most people treat their resume like a historical document, a boring chronological list of every job they've ever had and every class they've ever taken. This is a fatal mistake. Your resume is not a history book. It is a one-page, high-impact marketing brochure, and the product is you. Its only job is to get you the interview. That's it. It has about 6 seconds to convince a recruiter not to throw it in the digital trash bin. So, how do we make those 6 seconds count? We start by ruthlessly cutting the fluff. The 2-page resume for a college student or recent grad? Gone. The fancy fonts, graphics, and headshots? Gone. They confuse the applicant tracking systems, the ATS bots that read your resume before a human ever does. We're building a document for both robot and human, and clarity is king. Your name and contact info go at the top. Clean, simple. Your LinkedIn and GitHub profile links are non-negotiable. They must be there. Next, a professional summary, not an objective. Nobody cares that your objective is to obtain a challenging position at a prestigious company. Of course it is. Instead, write a 3-sentence summary that's a highlight reel of who you are. Computer science graduate with a demonstrated passion for machine learning, proven through the development of a predictive text mobile keyboard that achieved 98% accuracy. Proficient in Python, TensorFlow, and AWS, seeking to apply data modeling skills to solve real-world business problems. See the difference? It's specific, it's confident, and it's packed with keywords. Then comes your skills section. Don't just list Python. That tells me nothing. Group your skills logically. Programming languages: Python, Java, C++. Web technologies: React, Node.js, HTML/CSS. Databases: SQL, MongoDB. Cloud platforms: AWS S3, EC2. This makes it instantly scannable for both the ATS and the human recruiter looking for specific qualifications. Now, the most important part, your projects section. For a new grad or someone early in their career, your projects are more important than your work experience, especially if that experience was lifeguarding or making sandwiches. Your projects are the proof, but don't just list them. For each project, you need to tell a microstory using the STAR method: situation, task, action, and result. Don't say, built a weather app. Say, developed a dynamic, real-time weather application to provide users with up-to-the-minute forecasts. That's the situation and task. Architected a full-stack solution using React for the front end and a Node.js/Express backend to fetch data from a third-party weather API. Implemented a clean, responsive UI/UX for seamless mobile and desktop viewing. That's the action. The result? The final application handled over 1,000 API calls per day during testing and achieved a 99% uptime. That's the result. Quantify everything. Use numbers. Numbers are the language of business and impact. Increased efficiency by 30%. Reduced database query time by 200 milliseconds. Process 10,000 lines of data. Numbers cut through the noise and prove you're not just a talker. You're a doer. Your resume is the movie trailer. It's fast, exciting, and makes people want to see the full feature film. And that feature film is your portfolio. A link to your GitHub profile is not a portfolio. A GitHub filled with a dozen forked repositories and half-finished tutorial projects is a liability, not an asset. It's a digital ghost town. Your portfolio is your curated gallery, your personal museum of achievement. It should host your 3 best, most polished projects. Quality, not quantity. Each project in your portfolio needs a phenomenal README file. This is where you go from being a coder to being an engineer and a storyteller. Your README is the museum plaque next to your masterpiece. It must explain 3 things: the why, the how, and the what. The why. What was the problem you were trying to solve? Why did this project need to exist? I was frustrated with existing budget apps, so I built a smarter one that uses machine learning to categorize expenses automatically. This shows initiative and problem-solving skills. The how, what technologies did you use, and more importantly, why did you choose them? I chose React for its component-based architecture, which made the UI manageable, and PostgreSQL for its data integrity and reliability. This demonstrates thoughtful engineering decisions, not just a random grab bag of tech. Talk about the challenges you faced and how you overcame them. I ran into a significant performance bottleneck with API calls, which I solved by implementing a caching layer with Redis, reducing latency by 70%. This shows resilience and a deep understanding of your work. And finally, the what? Show me the final product. Include high-quality screenshots. Even better, an animated GIF of the project in action. Best of all, a live, clickable link to the deployed application. There is nothing more powerful than letting a recruiter or hiring manager actually use the thing you built. It removes all doubt. It's tangible proof of your ability to ship a finished product. A great portfolio with 3 well-documented, impressive projects is infinitely more valuable than a resume that lists 10 mediocre ones. It's your undeniable evidence. But even with a killer resume and a stunning portfolio, there's a third, more elusive piece of the puzzle. It's the narrative that ties it all together. It's your personal brand. Branding isn't just for corporations. In the job market, you are the CEO of Me Incorporated. Your brand is the story people tell about you when you're not in the room. You have a brand whether you cultivate it or not. The question is, are you going to control the narrative, or let it be defined by a flat, one-dimensional resume? Your brand starts with consistency. Your LinkedIn profile shouldn't just be a copy-paste of your resume. Your LinkedIn headline is prime real estate. Don't just say student at State University. Say aspiring software engineer, Python, AWS, and machine learning enthusiast. It's a banner ad for your career. Use the About section to tell your story in a more personal first-person voice. Talk about your passion. What got you into computing? What problems are you excited to solve? Your GitHub profile is a core part of your brand. Customize it. Pin your top 3 portfolio projects so they are the first thing anyone sees. Have a professional profile picture. Write a short bio. Contribute to open source, even if it's just fixing a typo in documentation. It shows you're a team player and engaged in the community. And for those willing to go the extra mile, consider creating content. You don't need to be a famous blogger or YouTuber. Start a small blog on a platform like Medium or Dev.to. Write about a project you built. Explain a difficult concept you just learned. This does 2 incredible things. First, it forces you to understand the material on a much deeper level. You can't explain something well until you truly know it. Second, it creates a public artifact of your knowledge and your ability to communicate complex ideas. A skill that is desperately sought after. When a hiring manager Googles your name and they will, what do you want them to find? A random collection of social media accounts? Or a thoughtful article you wrote explaining the nuances of asynchronous JavaScript? Your resume gets your foot in the door. Your portfolio proves you can do the work. But your personal brand is what makes you memorable. It's the X factor that turns you from applicant number 734 into that impressive candidate who's really passionate about cloud security. It's the story that makes them want to hire not just a set of skills but a person. Building this digital presence isn't a one-day task. It's a project in itself. It takes time, effort, and iteration. But this is the work that separates the applicants from the hires. This is how you stop competing and start getting chosen. You've built the skills, you've built the projects. Now, you've built the platform to showcase them. You're no longer just sending out applications into the void. You are a professional presenting a compelling case for why you are the solution to their problem. With this foundation in place, you're ready. You're ready to step into the arena and actually start applying. But applying for jobs is a strategy game, not a numbers game. Sending out 500 generic applications is a recipe for burnout and despair. We need a smarter approach. We need to learn how to find the right roles, how to network effectively without being awkward, and how to talk to the humans on the other side of the screen. We need a battle plan for the job hunt itself. And this battle plan isn't about brute force. It's not about sending out 1,000 applications and praying to the silicon gods that one sticks. That's the digital equivalent of carpet bombing and hoping you hit a target. It's inefficient, it's demoralizing, and it's why so many brilliant, capable people burn out before they even get their first interview. Your job hunt is a strategic campaign, and you are the general. Your mission is to get a great job, not just any job. And our campaign has 3 primary fronts, a 3-pronged attack that, when executed correctly, makes you impossible to ignore. The first prong is what I call the air support. This is your online application game. Most people think this is the only front, which is why they fail. But it's still critical, because a strong aerial presence clears the way for everything else. This is where we conquer the infamous black hole of online job portals. You click submit, and your resume vanishes into the digital ether, never to be seen again. Why? Because you're not fighting a human. You're fighting a machine. An applicant tracking system, or ATS. This software is the gatekeeper for 99% of large companies. It scans your resume not for elegance or potential, but for keywords. It's a bouncer with a checklist, and if you don't have the right words in the right places, you're not getting in. So, how do we beat the machine? We think like the machine. First, your resume is not your life story. It is a marketing document. I want you to repeat that. A marketing document. Its only purpose is to sell one product, you, for one specific job. This means the era of the one-size-fits-all resume is over. Dead. Buried. For every single job you are genuinely excited about, you will create a tailored resume. Here's the tactical breakdown. Open the job description. Copy and paste it into a word cloud generator online. What are the biggest words? Python, AWS, Agile, data structures, REST APIs. Those are your keywords. Your resume must contain those exact terms. Not synonyms. Not close approximations. If the job description says SQL, your resume better say SQL, not database management. The machine is dumb. You have to be smart. Next, we upgrade your bullet points from passive descriptions to active accomplishments using the STAR method. Situation, task, action, result. Never, ever write a bullet point that just says wrote Python scripts. That's a task. It's meaningless. Instead, you write, developed and deployed a Python automation script, action, to process and validate daily sales data, task, which reduce manual data entry errors by 95% and save the team 10 hours per week, result, during a critical Q4 reporting period, situation. See the difference? One is a chore. The other is a victory. Every bullet point on your resume needs to be a victory. Quantify everything. Use numbers. Percentages, dollar amounts, time saved. Numbers are the language of business and the language of results. This is how your resume gets past the ATS and impresses the human who finally reads it. That's your air support. It's precise, it's powerful, and it gets you on the radar. But we don't stop there. The second prong of our attack is the special forces. This is your targeted outreach. While your air support is bombarding the main gates, your special forces are finding a way to sneak in the back door. This is where you bypass the HR black hole entirely and talk directly to the people who actually make hiring decisions. Your mission here is to identify the hiring manager or a senior engineer on the team you want to join. LinkedIn is your best friend here. Don't just search for the company. Search for job titles at that company. Look for software engineering manager at Google or Lead cloud engineer at Microsoft. Find the person who would be your future boss. Now, here's the critical part. You do not message them and say, "Please look at my resume, I need a job." That is the equivalent of a soldier parachuting into enemy territory and immediately surrendering. You are a professional, a peer in training, not a beggar. Your goal is to start a conversation by demonstrating genuine interest and respect for their time. You're going to send them a connection request with a personalized note. Something like this: "Hi name. I came across your profile while researching cloud engineering roles. I was really impressed by the work your team did on the mention a specific project you found on their blog or in the news. I'm an aspiring cloud engineer myself, and I'd be grateful for the chance to ask you 2 quick questions about your journey in the field." No resume, no job pitch, just a few minutes of your insight. It's short, it's specific, shows you did your homework, and most importantly, it has a non-ask. You're not asking for a job, you're asking for advice. People are biologically wired to want to help and to share their own story. You'd be shocked at how many people will say yes to a 15-minute virtual coffee chat. In that chat, you ask smart questions, listen more than you talk, and at the very end you can say, "This has been incredibly helpful. Based on our conversation, I'm even more excited about the possibility of contributing to a team like yours. Would you be open to me sending over my resume in case a fitting role opens up?" Boom! You've just bypassed 100,000 other applicants. You're no longer a PDF in a database. You're a name, a face, and a great conversation. That is a special forces operation. Finally, we have the third prong, the intelligence network. Your network is your intelligence agency. It provides you with crucial information, finds hidden opportunities, and vouches for you behind enemy lines. This isn't about going to stuffy networking events and awkwardly handing out business cards. This is about becoming an active member of your professional community. Where do engineers hang out? They're on GitHub, contributing to open source projects. They're on Stack Overflow, answering questions. They're in niche Discord and Slack communities dedicated to specific technologies like React or Kubernetes. They're at local tech meetups. Go there. Don't go to sell yourself. Go to learn and to give. The golden rule of networking is to give value before you ask for it. Answer someone's coding question. Share a fascinating article. Compliment someone's project on GitHub. When you become a known entity, a helpful voice in the community, people will want to help you. They'll hear about an opening on their team before it's ever posted online and think of you. This is how you get the holy grail of the job hunt. The employee referral. A referral from a current employee is the single most powerful weapon in your arsenal. It bypasses the ATS, it lands your resume directly in the hiring manager's inbox, and it comes with a stamp of trust. Studies show that referred candidates are up to 10 times more likely to be hired than those who apply through a career site. Your entire networking effort, your entire Special Forces outreach, is ultimately about building a genuine connection strong enough that someone is willing to put their name on the line for you. So that's the battle plan. The 3-pronged attack. You have your air support of perfectly tailored, ATS-beating resumes for online applications. You have your Special Forces, conducting targeted outreach to key decision-makers. And you have your intelligence network, building real relationships and uncovering opportunities before anyone else. You stop being a passive applicant waiting to be picked, and you become an active strategist, creating your own opportunities. With this plan, you will get interviews. It's not a matter of if, but when. And once those calls and emails start rolling in, the battlefield shifts. You've breached the gates. Now, you have to win the war, room by room, conversation by conversation. You have to face the trials. The phone screen, the dreaded technical interview, the behavioral deep dive, and the salary negotiation. Each one is a boss battle with its own rules, its own traps, and its own secrets to victory. And mastering those is exactly what we're going to break down next. Let's start with the first gatekeeper, the one that sends shivers down the spine of even the most confident coders, the technical interview. This isn't a test of what you've memorized. It's a performance. It's a live demonstration of your problem-solving mind in action. The biggest mistake people make is thinking the goal is just to get the right answer. That's wrong. The goal is to show the interviewer how you arrive at an answer. They want to see your thought process, your communication skills, and your ability to handle pressure. They're not just hiring a pair of hands to type code. They're hiring a brain to solve problems, and this is your audition. The foundation of this audition is, of course, data structures and algorithms. Everything we talked about in the learning phase, the arrays, the hash maps, the trees, the graphs, the sorting and searching algorithms, this is where it all comes to life. But knowing them isn't enough. You have to be able to wield them under pressure on a problem you've never seen before. So how do you train for that? The answer for most is a single word: LeetCode, or HackerRank, or any similar platform. But here's the secret the top performers know. More is not better. Better is better. Mindlessly grinding through 500 problems is a recipe for burnout and shallow knowledge. You'll recognize problems, but you won't understand the underlying principles. Instead, you need a strategy. You need to focus on patterns, not problems. Your new Bible should be a curated list, something like the Blind 75 or my personal recommendation for 2026, the NeetCode 150. These lists are brilliant because they don't just give you random problems. They give you a curated set of high-frequency questions that cover all the essential patterns. You have the two-pointers pattern, the sliding window, binary search, breadth-first and depth-first search, dynamic programming, and so on. There are about a dozen core patterns that, once you truly understand them, can be used to solve 90% of the problems you'll ever face. Your training regimen should look like this. Pick a pattern, say sliding window. Watch a video that explains the core concept. Then, do 5 or 6 LeetCode problems from that category. First, you'll struggle. That's the point. The goal isn't to solve it in 15 minutes. The goal is to wrestle with it. Spend a solid 30 to 45 minutes trying to figure it out on your own. If you're stuck, don't just look at the solution. Look for a small hint. If you're still stuck, then look at the solution. But don't just read it and move on. You must understand it so deeply that you could explain it to a 5-year-old. Code it out yourself without looking. Then, and this is the most important part, come back to that same problem 2 days later, and then a week later, and solve it again from scratch. This is active recall and spaced repetition. It's how you burn these patterns into your long-term memory. You're not memorizing code. You're internalizing a way of thinking. Once you've built this arsenal of patterns, it's time to focus on the performance itself. The live coding interview. You need a framework, a script you can run every single time, that showcases your brilliance. Here it is, a 5-step process to dominate any coding challenge. Step 1, clarify. The moment the interviewer gives you the problem, do not start coding. I repeat, do not start coding. Your first job is to be a detective. Repeat the problem back in your own words to ensure you understand it. Then ask clarifying questions. What are the constraints on the input size? Can the numbers be negative? What should I return if the input is empty? This shows you're thorough and detail-oriented. It also buys you precious seconds for your brain to start working in the background. Step 2, brainstorm. Talk through a simple brute force solution first. Even if it's slow and inefficient, this is a massive psychological power play. It immediately establishes that you can solve the problem. It gets a working solution on the table and removes the pressure of finding the perfect answer right away. You'd say something like, okay, my first thought is we could use a nested loop to compare every element with every other element. I know this would be O of n squared, which probably isn't optimal, but it would give us the correct answer. Shall I start with that? Or should we look for a more efficient approach? Step 3, optimize. This is where you shine. Now you transition from the brute force to the optimal solution. You use the patterns you've practiced. You'd say, to improve on that O of n squared complexity, we could probably use a hash map. By storing the elements we've already seen, we can check for the complement in O of 1 time. This would bring our overall time complexity down to O of n, which is much better. You're not just giving an answer, you're explaining the why. You're demonstrating your knowledge of time and space complexity. You're leading the interviewer on a journey from a bad solution to a great one. Step 4, code. Only now, after you've agreed on an optimal approach with your interviewer, do you start writing code. And as you write, you talk. Think of yourself as a sports commentator for your own code. Okay, I'm initializing a hash map here to store the values we've seen. Now I'll start my loop through the input array. Inside the loop, the first thing I'll do is calculate the complement we're looking for. This verbalization is critical. It prevents awkward silences and shows the interviewer exactly what you're thinking. If you make a small mistake, you can even catch it out loud, which shows self-awareness. Step 5, test. Once the code is written, don't just say, I'm done. You're not. You need to validate your work. Say, all right, let's test this with a few examples. Walk through a simple case. Then test the edge cases you asked about in the beginning: an empty array, an array with one element, an array with duplicate numbers. You are methodically proving that your code is robust and correct. This final step shows a level of professionalism that separates junior candidates from future senior engineers. This 5-step framework, clarify, brainstorm, optimize, code, test, turns a terrifying interrogation into a structured, collaborative problem-solving session that you control. And for those of you targeting top-tier companies or more senior roles, there's another beast: the system design interview. This isn't about writing code on a whiteboard. It's about architecting entire systems. The question might be, design Twitter snooze feed, or design a URL shortener like BFLY. They want to see how you think at a massive scale. You'll be talking about load balancers, databases, SQL versus NoSQL, caching strategies, CDNs, and API design. The key here isn't to have one right answer, but to navigate trade-offs. You're showing them you can think about reliability, scalability, and cost. For this, you need to study. Resources like Grokking the System Design Interview or Alex Sue's books are the gold standard. You're not expected to be an expert as a new grad, but showing familiarity with these concepts can set you miles apart. Mastering the technical interview proves you have the hard skills, proves you can do the job. But that's only half the equation. Companies don't just hire skills, they hire people. They need to know if you're someone they want to work with day in and day out. They need to know if you can handle conflict, work in a team, and learn from your mistakes. And to find that out, they deploy the second boss battle, the behavioral interview. This isn't a personality quiz. It's not a friendly chat. The behavioral interview is a strategic interrogation of your past to predict your future performance. It's the stage where two candidates with identical technical scores walk in, and only one walks out with the offer. Why? Because the one who wins proves they're not just a good coder, they're a good colleague. They prove they're not a risk. Every year, brilliant engineers, people who can reverse a binary tree in their sleep, absolutely bomb this section. They treat it as an afterthought. They give vague, generic answers. They ramble. They failed to understand the question behind the question. When an interviewer asks, "Tell me about a time you disagreed with a manager," they aren't asking for gossip. They're asking, when faced with authority, do you collapse or do you communicate? Do you argue emotionally or do you present data logically? Are you a problem maker or a problem solver? Your entire goal in this interview is to prove you are a low-risk, high-reward hire. And the only way to do that is by telling compelling stories. Not just any stories. Stories with a beginning, a middle, and a quantifiable end. Stories that follow the single most powerful framework ever devised for behavioral interviews: the STAR method. Situation, task, action, result. Burn this into your brain. This is your weapon. This is your shield. This is how you turn a vague, anxiety-inducing question into a showcase of your competence. Let's break it down. First, situation. This is the setup. You need to provide just enough context for your story to make sense. Briefly, what was the project? Who was on the team? What was the overall goal? We're talking 2, maybe 3 sentences. The mistake people make here is spending 5 minutes describing the company history. The interviewer doesn't care. Get to the point. Second, task. What was your specific responsibility in this situation? What was the concrete goal you were assigned or took upon yourself? This is crucial. It defines your role in the narrative. It's not what the team had to do. It's what you had to do. My task was to refactor the legacy payment processing module to reduce transaction failures. Clear. Specific. Third, and this is the absolute heart of your answer, is action. What did you do? Not what you thought about doing. Not what the team did. What were the specific, concrete steps you took to accomplish the task? Use the word I. I analyzed the existing code base. I designed a new error handling protocol. I wrote a suite of unit tests. This is where you demonstrate your thought process, your skills, your initiative. Did you encounter a problem? How did you solve it? Did you need to persuade someone? How did you do it? This section should be the longest, most detailed part of your answer. Finally, result. This is the punchline. This is what separates a good story from a great one. You must quantify your outcome. Numbers are the language of business and engineering. They are undeniable proof of your impact. As a result, we reduced payment transaction failures by 40%, which saved the company an estimated $20,000 per month in lost revenue and support costs. See the power in that? It's not just, I fixed the bug. It's, I delivered measurable business value. If you can't find a hard number, use qualitative results. The result was that my manager adopted my new documentation template for the entire department, which streamlined our onboarding process for new hires. Let's see this in action. The classic, dreaded question. Tell me about a time you made a mistake. A terrible answer, the one that gets you rejected, sounds like this. Yeah, one time I pushed some code that had a bug in it, but we found it and fixed it pretty quick. It was a good learning experience. That tells the interviewer absolutely nothing, except that you're unprepared and can't self-reflect. Now let's use the STAR method. Situation. In my last internship, I was part of a team migrating our user database from a legacy system to a new cloud-based solution. It was a massive project with a very tight deadline. Task. My specific task was to write a script that would migrate user profile data. It was critical that no data was lost, and that all user privacy settings were correctly mapped to the new system's format. Action. I was hyper-focused on the deadline. I wrote the script, tested it with a sample dataset, and it worked perfectly. Feeling confident, I told my manager I was ready to run it on the full staging database. What I failed to do in my rush was account for a rare edge case involving accounts created before 2015 that used a deprecated authentication method. I didn't test for it. I ran the script and it corrupted the data for about 500 of our oldest user accounts. The moment I saw the error logs, I knew what I'd done. My first action was to immediately communicate. I didn't try to hide it. I went straight to my tech lead, explained exactly what happened, what my mistake was, skipping the deep dive on legacy account types, and I took full ownership. Then I worked through the night, collaborating with a senior engineer to write a patch. I analyzed the corrupted data to find a pattern, developed a script to reverse the incorrect mappings, and this time, I created a specific test suite just for these legacy accounts. I tested it, had him review it, and then we ran the correction. Result. We successfully restored all the corrupted data within 12 hours, with zero permanent data loss. The project was delayed by only 1 day. But the most important result was what I learned. I created a personal pre-migration checklist that included deep diving on edge cases and legacy data, which I then shared with my team. It was actually incorporated into our official best practices. It was a stressful mistake, but it taught me that meticulousness is more important than speed, and that immediate, transparent ownership of an error is the only way to solve it. Do you feel the difference? One is a dismissal. The other is a masterclass in accountability, problem-solving, and maturity. You didn't just tell them you made a mistake. You showed them exactly how you handle yourself under pressure. You proved you're a safe pair of hands. You need to prepare for this. You cannot improvise these stories on the spot. Before your interviews, you need to build your personal story bank. Sit down and identify 5 to 7 of your most significant accomplishments, challenges, and projects. From your internships, your capstone project, even a complex personal project. For each of these 5 to 7 situations, write out the full STAR response. Write out the situation, the task, your actions, and the quantifiable result. Practice telling these stories. Record yourself on your phone and listen back. Do you sound confident? Are you rambling? Is the result clear and impactful? One great story can be adapted to answer multiple questions. A story about a conflict with a teammate could also be used for a question about leadership, persuasion, or handling a difficult project. Because when they ask, "Tell me about a time you showed leadership," they're really asking, "Can you influence people without direct authority?" When they ask, "Tell me about a time you had to work with a difficult person," they're asking, "Are you emotionally intelligent enough to navigate professional friction and still get the job done?" And when they ask, "Tell me about a time you had to deal with ambiguity," they're really asking, "When you don't have a clear roadmap, do you freeze, or do you forge a path forward?" The technical interview proves you can do the job. The behavioral interview proves you can do it there, with them. It proves you're a force multiplier, not a source of drama. It's where you transition from being a candidate on paper to being a future colleague in their mind. Master your stories, master the STAR method, and you will master this crucial stage. Because once you've proven you have the technical chops and the professional maturity, there's only one final hurdle standing between you and that 6-figure offer. And that final hurdle is the one that turns all your hard work into cold, hard cash. It's the negotiation. For most people, this is the most terrifying part of the entire process. Feels confrontational, awkward, even greedy. But I need you to completely reframe how you see this moment. This is not a confrontation. It is the final collaborative step in proving your value. A company doesn't give you an offer because they're being nice. They give you an offer because they believe that for every dollar they invest in you, you will generate $5, $10, maybe $100 of value back for them. Your salary is not a gift. It is a fraction of the value you are expected to create. And here's the secret the best candidates know. Companies expect you to negotiate. In fact, when a strong candidate accepts the very first offer without a single question, it can almost be a red flag. It can signal a lack of confidence or a lack of understanding of their own market value. So let's banish the fear. This isn't about being greedy. It's about being compensated fairly for the immense value you've spent the last 4 years building. This is where we secure the six-figure part of our 2026 roadmap. Your power in any negotiation comes from one thing: preparation. You don't walk into this conversation blind. You walk in armed with data. Your first step is to research and determine your market value with surgical precision. Use sites like levels.fyi, Glassdoor, and PayScale. But don't just look at the average salary for a software engineer. That's useless. You need to filter. Filter by location. San Francisco is not the same as Austin, which is not the same as Raleigh. Filter by years of experience. You are an entry-level or junior engineer, not a senior. Filter by specific skills. Engineers with in-demand specializations like machine learning or cybersecurity command a premium. Gather all this data and triangulate it. You're looking for a realistic range. From this research, you will define 3 critical numbers. First, your walk-away number. This is your absolute floor. It's the number below which you will respectfully decline the offer, no matter how much you like the company. This number protects you from making an emotional decision you'll regret. Second, your target number. This is the realistic, well-researched number you are aiming for. It's ambitious but firmly grounded in the data you've collected. And third, your dream number. This is the top of the range, the number that would make you do a silent fist pump in your chair. This is the number you might use to anchor the negotiation high. Next, you must understand the concept of total compensation, or TC. This is where amateurs get tripped up. They fixate on the base salary, but pros look at the whole picture. Total compensation is typically made up of 3 parts. 1. Base salary. This is the predictable, guaranteed money that hits your bank account every 2 weeks. It's important, but it's not everything. 2. Bonuses. This can include a signing bonus, which is a one-time cash payment to get you in the door, and an annual performance bonus, which is a percentage of your salary based on your and the company's performance. And 3. The most powerful component, equity. This means ownership in the company, usually in the form of restricted stock units or RSUs for public companies or stock options for startups. An offer with a $110,000 base salary and $40,000 in stock per year is a $150,000 total compensation package. It is significantly better than a flat $120,000 salary with no equity. Understanding TC is your superpower. Okay, you've done your research. You have your numbers. You understand TC. Now for the negotiation itself, the dance. The first and most important rule is this: whenever possible, do not be the first person to name a number. Recruiters are often trained to ask, "So what are your salary expectations?" They ask this because if you say, "I'm hoping for $95,000, and their approved budget for the role was actually $110,000 to $130,000, you just single-handedly saved them $15,000 a year. You anchored the entire negotiation low, and you'll never get that money back. So, when they ask for your number, you deflect gracefully. You can say something like, "I'm really focused on finding the role that's the best fit for my skills and career goals. I'm confident that if this is the right match, we can agree on a compensation package that's fair and competitive in the current market." Or if they press you, you can flip it back to them by showing you've done your homework. Based on my research for a computer engineering role with this level of responsibility here in Seattle, I'm seeing a total compensation range anywhere from $120,000 to $150,000. I'd be interested to know what you've budgeted for the position. You see what you did there? You didn't give your number. You stated the market's number and put the ball back in their court. Eventually, they will present you with an offer. Let's say the recruiter calls you ecstatic. "We loved you. We'd like to extend an offer for a base salary of $105,000, a $5,000 signing bonus, and $20,000 in stock." Your heart is pounding. This is it. Your instinct is to scream, "Yes." Do not do this. Your response should be calm, professional, and grateful. You say, "Thank you so much. I am incredibly excited about this opportunity and the possibility of joining the team. This is wonderful news. Could you please send the full offer details over in an email so I can review them carefully?" That's it. You thank them, you show excitement, and you ask for it in writing. This does 2 things. First, it gets you a formal document to review, preventing any miscommunication. Second, and more importantly, it buys you time. It gets you off the phone and allows you to detach emotionally, look at the numbers objectively, and plan your counteroffer. Now, you analyze the written offer. It's a good offer, but your research showed that your target was closer to a $115,000 base and you know their competitors offer a $10,000 signing bonus. It's time to formulate your counter. When you call the recruiter back, you structure the conversation like this. First, you reiterate your enthusiasm. Hi, recruiter's name. Thanks again for sending that over. I've had a chance to review it, and I want to reiterate how incredibly excited I am about this role and the projects we discussed. Always start with a positive. Make them want to fight for you. Second, you state your case by tying it directly to your value. This is not about what you want. It's about what you're worth. Based on my specific experience in cloud infrastructure automation, which I know is a major priority for the team, and considering the market data for this type of role, I was expecting a base salary closer to the $118,000 range. Notice you gave a specific number, not a range. It's confident. It's direct. Third, you address other components. Additionally, I'm considering another opportunity that includes a $10,000 signing bonus. My strong preference is to join your team, and I was hoping you might be able to match that to make my decision easier. Using a competing offer, if you have one and it's genuine, is the single most powerful piece of leverage you can have. And then, after you've made your case, you do the hardest part of all. You stop talking. The silence might feel awkward, but let them be the next one to speak. The recruiter will likely say, "Okay, thank you for sharing that. Let me take this back to the hiring manager and the compensation team and see what we can do." And then you wait. A day or two later, they'll come back. Maybe they meet you all the way. Maybe they meet you in the middle. Okay, we can bring the base salary up to $112,000 and increase the signing bonus to $8,000. And at that point, you have successfully negotiated your salary by $10,000. Over 4 years, that's a $40,000 difference from a single 5-minute phone call. And that, my friends, is the power of negotiation. This entire roadmap, from your first day of freshman year to this very moment, has been a series of strategic steps. It was about building a foundation of knowledge, then layering on projects that prove your skill. It was about networking not just to get a referral but to build a community. It was about crafting a resume that tells a story, and then mastering that story in the interview. And it culminates here, in this final step, where you calmly and confidently state your value and are compensated for it. This 2026 roadmap was never just about getting a job. It's about launching a career. It's about taking control of your future, building something meaningful, and creating a life of financial freedom and intellectual challenge. The path is not easy. It demands discipline, curiosity, and a relentless desire to learn and grow. But it is not a mystery. It is a blueprint. And now you have that blueprint. The next step is no longer mine to dictate. It's yours to take. The journey to a 6-figure computer engineering career begins not in 2026, but right now with the very next decision you make. Go build your future.